lecture 5. And last time I think we discussed this, we were starting with the discussion of beats, na? And I gave you a graphical representation and all those things. Animation bhi ek dikhaya tha, I think. Yes? So let's come back to that and complete it. Beats. And basically I said ki beats is just an interference, but interference in time. And what do I mean by that? That the final resultant amplitude will be a function of time, na? So let's say this is interference in time. Please write with me, huh? That means the final amplitude will be a function of time. We can already anticipate such thing. And just by common experience we can even say ki maybe it will be some kind of sinusoid. Okay? And the equations that I found last time, the two waves that we were considering were a1 sine omega 1t and a2 sine omega 2t. Yes? And then when you hear it at a certain specific location, then the final thing will just be superposition of the two, and that is given by what? By the superposition principle, that y is equal to y1 plus y2. Now it's not necessary for the whole derivation, but I will assume that the amplitudes are equal, huh? and then I will do the, it's just for simplicity, it's not necessary. Let's assume a1 equal to a2, which is equal to a0. Then at the end you get a0 sine omega 1t plus sine omega 2t, something like this. But now this looks to me like sine a plus sine b. And what is that equal to? Sine a plus sine b. What is that equal to? Yes, somebody tell. 2 sine a plus b by 2 cos of a minus b by 2. Yes, then following the same thing, what will I get? Y to be a0, so there will be a 2 a0 sine of omega 1 plus omega 2 by 2 into t, and there will be a cos of, acha, it doesn't really matter if I write omega 1 minus omega 2 ya phir omega 2 minus omega 1, because cos is an even function. So I will write by 2 into t. This is the final wave that I am getting. Okay, I can rewrite this to be something like y is equal to 2a0 cos omega 1 minus omega 2 divided by 2 into t sine omega 1 plus omega 2 by 2 into t. Okay, I just shifted the other thing. Then this thing, the whole thing, the first thing, I will call it to be my new amplitude. Do you remember in stationary waves what we used to find? 2a0 sine kx cos omega t. And then we used to say this is a amplitude which is a function of space, my final amplitude, and for each location I will find an amplitude of the whole thing, like this, all particles are following this sine kind of function. And what does this cos omega t term does? It modulates the whole thing. ये wave जो है ये ऐसे दिख रहा है, it keeps on changing. This is station, that's why we make another lobe. It's just another possibility, it keeps on changing with that. So in a similar way, this looks to me like the final amplitude, and this to be my modulating word. And how does the beat look like? Beat का कल मैंने diagram बनाया था ना, increase, decrease, increase, decrease. So some positions it increases. So ऐसा कुछ रहता है. Something like this, and this is how a beats are formed. So it keeps on changing with time as well, na? And this is how the pattern looks like. Does it make sense to you? Yes, this is our final function even predicts with some frequency, with some different frequency, omega 1 minus omega 2 divided by 2, and this is my modulating frequency. I did not write the kx terms, but imagine if there were to be some kind of kx term here and here, then that will mean that the whole thing is moving as well, na? Hai na? Because it will have some speed. Yes or no? If I write my omega term and k term, तो k term मैंने omit किया just for simplicity, but if you write the kx term, you will find a speed to the whole wave, and then you can say, then it only makes sense that the beats also move. They move. They are basically a superposition of sound waves. Sound waves move, so they also move, na? So they move with this velocity, this thing which actually carries the whole thing with this velocity. And what is this velocity? This is the amplitude, the velocity with which the amplitude increases and decreases. So there are two terms here. Be very careful of it. Do you understand? Good. So it's written till here. There is something called as beat frequency, and beat frequency is given to be, I'm not doing the derivation for it, but beat frequency is given to be mod of f1 minus f2. Mod of f1 minus f2. Okay? Can I scroll? बोलो कोई प्रॉब्लम है इसमें? Yes, Virupaka. Are you understanding? Good. Is it visible to everyone? Visible to backbenchers? This is my time varying amplitude, which we already anticipated. And we found it by simple mathematics, just by 2 steps. And this is how a beat is formed. I think I've already shown you the animation and everything, na? So you have a clear picture in your head already. Good. If this is done, then tell me, we can do some problems. And I think what happened was, if it goes, the light goes out again, then tell me. It's green right now. तो वो लास्ट के 10-15 मिनट्स चला गया था, तो आवाज़ ही नहीं आई वीडियो में. आई विल स्टिल अपलोड इट, बट जस्ट लुक एट द थियरी एंड ट्राई टू मेक सेंस ऑफ व्हाट आई एम सेइंग, बिकॉज इन द लास्ट 15 मिनट्स देयर इज़ नो ऑडियो. ठीक है? ओके. एनीवेज, I will upload that lecture as well today, and hopefully this lecture as well. Is it done? Can I write the question? So I'm writing in this part. Once you are done, just write the question and attempt it. Attempt. I will start in 3-4 minutes, okay? बोल 306 let me check. Yes, 306 is correct. Anybody else with the answer? I will explain everything. I've given you time to think. Should I start or should I wait? Start? Okay. You have two tuning forks, and if you don't know tuning forks, so ऐसे U-shaped figure कुछ तो रहता ना, and then you pluck it, then you'll get sound waves, है ना? You have two tuning forks, and they create a beats of beat frequency 6 beats per second. So FA minus FB, mod of FA minus FB is given to be 6. This is the first bit of information. Frequency of A is 300 Hertz. So this is 300 minus FB is equal to 6. When B is slightly waxed, the beat frequency decreases. Okay? The beat frequency decreases, then find the original beat frequency. So after waxing, you will get some kind of 300 minus FB dash. I will call it dash after the waxing, and this is going to be less than 6. This we know. What are the possible values of FB that can come out of it? 294 Hertz and 306 Hertz. Yes? Correct? Now when you slightly wax something, when you wax a prongs या फिर this tuning fork, what happens? The frequency decreases. You should know this. तो मैं ये लिख देता हूँ information. When a tuning fork is waxed, its frequency decreases. ठीक है? Its final frequency is going to decrease. So let's say whatever you assume, there are two initial possible values. Na? Out of these things, when you wax, your beat frequency should decrease. So let's say if my initial value were to be 294, if FB equal to 294 Hertz, when you wax it, this frequency will decrease. Yes or no? Let's say it decreases by some value, let's say 2 Hertz. Just for the argument's sake, FB becomes FB dash 292 Hertz. 292 Hertz. If this is so, then what is my final beat frequency? Then FB dash minus FA is going to be equal to what? 292 minus 300. It's 8, but it is greater than 6. ये तो नहीं चाहिए. We don't want this. Let's take another possibility. If FB is equal to 306 and you decrease it by 2, so now it has 304 Hertz. Then what is the possibility now? That is 4, which is less than 6. So which is the correct frequency then? 306 should be the correct frequency, because when you wax something, its frequency decreases when you wax a tuning fork. This is very important. Do you understand? Yes? Good. Copy and then let me write the next question. So that means the correct answer is 306. This is my correct answer. Bolo. If FB is decreasing by 14,
then even we get 292, and then the file output will also be 8, right?
कितना किया है?
Slightly.
स्लाइटली. तो फिर मैंने फ्रीक्वेंसी डिक्रीज भी बहुत स्लाइटली किया. ठीक है? इज इट ओके? Now that you know how to apply it in a given question, I expect more answers this time. This is the question at hand. Now attempt. Tout. Big tout. Tout is tight. Your tension increases. Actually, I gave away the question, but ठीक है. Come on, give me answers. Jaldi, jaldi. Why? Give me a. Tell me reasoning. Think it.
Again, if we decrease it by 2 hertz, possible values are 395 and 405.
ठीक है.
If we decrease it by 2 hertz again.
But I don't think the. What is the condition given? 390. जो भी आंसर दे रहा है, give me a reasoning with it. Okay.
So once you change the frequency, when it's lower, it increases.
So what was the initial frequency when it was not out?
400.
हाँ तो what is, and you are saying your frequency should increase, then you are saying 395 hertz.
So tension will increase.
हाँ, tension will increase. So frequency increase होएगा या decrease होएगा?
The frequency will decrease.
Frequency will decrease. Frequency decreases when tension increases, right? Correct. हाँ. Okay. So then what can you say? Then
Saying that he is wrong.
he is wrong. Then what should be the answer?
405.
405 is correct. And your reasoning is also correct. That frequency is directly proportional to root T. क्या बोलना है? हाँ, अभी सब पढ़ाऊंगा, बता रुक जाओ. Should I start? So you have a violin, on that it has a string, a stretched string, and what is the velocity of a sound on a stretched string? Root T by mu. And what is the frequency given to be? V by lambda, that means frequency is proportional to root of T. So as the tension increases, the frequency should increase. This is what we have for violin at least. Now what happens? The initial frequency of violin is 400. Then you put a prong in front of it, you vibrate it with some frequency, and then you also tighten the string so that its frequency actually changes. And if you remember, beats are only produced when you take different frequencies. You remember, even in my derivation, I did not take omega 1 and omega 2 to be same. I blatantly write them to be different. Anyways, so what is the beat frequency given to be? So f of violin dash minus f of t is equal to 5. Do you understand why I put a dash here? Because this is the frequency of the violin after it is tightened. The string is bit tight now. This is the condition. And what is the frequency of the prongs or the tuning fork? Tuning fork की frequency कितनी है? 400. Then what are the possible values of FV dash? 395 and 405. What was the initial value of FV? That was 400. Since frequency is proportional to root T, as you tighten it, your frequency should only increase. Then which is the possible condition in which the frequency increases? 405. Then what is the answer? 405. So this is correct. Do you understand? Yes? Fairly simple. Can I write the next question? I've been waiting 1 minute for you to write, and then I will go forward. Let me just write the question. Should I write it? Slightly harder. attempt.
What do you mean by file?
When you file a prong or a tuning fork, your frequency increases. Remember this.
But how is it even? It's a beat file.
फाइलिंग की वजह से लेट मी चेक वेट. यस, फाइलिंग की वजह से फ्रीक्वेंसी इंक्रीजेस. I will start in 3-4 minutes, okay? $254. I think that's incorrect.
So it should be 246.
246.
Because then if that increases to 248, then the total needs would decrease.
Yes, yes, correct. Correct. $246 is correct. Anybody else? Should I start with the question or should I wait? Hmm? 246 is correct. Yes, what about people there? Getting the answer? Okay, let me start with the question. It's given that you have two tuning forks with this P and Q, and when set vibrating gives off 4 beats per second. So initially Fp minus Fq mod is equal to 4 and Fq is given na 250. Fp minus 250 is equal to 4. That what are the possible values of Fp? 254 Hertz and 246 Hertz. Yes. Now if the prong is filed, the beats are reduced. So filing means what? That means frequency has increased, and it's given that Fp dash minus 250 should be equal to reduced to 2. Yes, reduced to 2. Now let's see if filing actually increases, then let's take both the possibilities. If Fp is equal to 254 Hertz, when you file it, then your frequency will only increase, na? Yes, then all the possible values through which you can increase the frequency, the final beat frequency will be even greater than your initial one, na? Yes, because if you take, let's say for example that Fp dash is equal to 256. Let's for example take by 2 values it has increased. Then what is Fp dash minus Fq? That's equal to 256 minus 250, that's 6, greater than 4. This is not what we want. We want it to be 2. And I took an example, but you can take all possible examples, and it's just simple logic that you will never get it to be less than 4. But if you take Fp to be 246, then can you see there is a one single possibility that exists, that under filing this becomes 248. And when it does, then what is the frequency then? That's 2. So what is the only possible case in which you can get this condition fulfilled? The only possible case is this one. If this were to be true, only then. So this is correct. Do you understand? Yes? If it,
Filing physically mean?
I don't remember exactly. I think these are the things that you come across even in 10th standard. Waxing, waning. सुना है कभी भी? Which board? सब CBSE के. I will introduce to all this term next time, ठीक है? Waxing, waning क्या होता है, filing ये सब क्या होता है बता दूंगा मैं. Okay? Anyways, copy. And once you are done, then tell me. I will give you a homework question, and then we can move on to a new topic. Can I write the homework question? चलो छापो. So हाँ बोलो. क्या चीज़? No, frequency decreases. Yes. हाँ? 252. Are you sure with the answer? 252 is correct. Yes. It was supposed to be a homework. Anyways, so let me go to the last topic of this chapter, and most probably by the next lecture we will end this chapter. This is called Doppler effect, one of the most important topic, and we will come across this Doppler effect even when we will study wave optics later on. ठीक है? But today I will do Doppler effect for sound waves. And sound waves are mechanical waves So the Doppler effect will also depend on the medium. ठीक है? There are many cases here, many cases, and it will get real complicated very fast. So please listen to it carefully. I will take special cases, try to build up the intuition, then I will give you the general formula, and we will try to look at it. So first let me write some terminologies which I will use. अच्छा, what is Doppler effect, by the way? What is it? कभी ऐसे have you heard this कि when you are standing at some place and maybe an ambulance is coming towards you, then the siren का frequency और how वो beep beep जो आवाज़ आती है, it's faster or it's much more when it is coming towards you. When it goes away, then वो हाँ the time period between two beats is कम, है ना? beats नहीं बोलना चाहिए, rather वो siren का आवाज़. The frequency, how frequently you will listen to this, that will decrease as it goes away from you, and when it is coming towards you, you feel like it has increased. So there is an apparent change in frequency when there is a motion of source, है ना? It can even be said that if you have an ambulance which is stationary and you are running towards it now, so you are the observer and you are running towards it, even still you will find that how frequently you will hear that avaz, that will be increased, and as you are running away from it, decreased. And we will try to find it by formula as well, by formulation, the whole thing. I will give you intuition by diagrams as well. Okay? So this is apparent change in frequency. Sound is? Sound of mosquito. You can say that, yes. Even still it applies.
It's louder when it comes.
No, it's not. Yes, it does become louder because obviously the source is moving towards you, and intensity is proportional to 1 over r square. As the distance between you and the source decreases, the intensity increases. I'm not talking about the intensity. I'm talking about how frequently you will hear that वो आवाज़ आती है ना. अब मैं वो आवाज़ निकालना नहीं चाहता, वरना तुम लोग बाद में उसी को क्लिप बना के उसको पता नहीं क्या मीम पेज पे डाल दोगे. वो आवाज़ आती है ना एम्बुलेंस की, पता है कि नहीं? नहीं पता? घर जाके सुनना. apparent change in frequency due to source, either motion of source. कोई मीम पेज ज़रूर बनाया होगा ना, पता है मुझे, कुछ ना कुछ होएगा. अभी मुझे पता नहीं है कहाँ पर है, क्या है सोर्स. हाँ बोलो. ड्यू टू आइदर मोशन ऑफ सोर्स और मोशन ऑफ ऑब्जर्वर. Yes, this is Doppler effect. We will try to derive all the possible formulas, and we will take simplest cases initially, and we will try to complicate it as we go on. ठीक है? The most simplest case that you can think of is that you have a source and you have an observer, and one of them is not moving, the other is moving, and they are moving in such a way that they are moving in a straight line that connects the two. Need not be true, need not be true, because you may move like this and your observer, the source may move like this. This is also possible. This is a 2D kind of motion where the velocity vectors are making some angle theta, not angle 0. I will take the simplest case where they are actually making 0 angle. यहाँ पर observer, यहाँ पर source है, and it's moving towards me or away from me. We will start with simplest cases. And let me give you some terminologies. So Vs will no longer be velocity of sound but velocity of source. Vo, velocity of observer. Vm, velocity of medium. V, velocity of sound. This is the terminology which I will use. ठीक है? Is it okay? I will start with some special cases. So if you have written this, then let's start with it. Special cases. From these special cases, we will try to build up an intuition. Case 1. And the case 1 is source not moving, source at rest, and observer is moving. Observer is moving. Don't talk. Then what will you have? Let's take the diagram, and the diagram will be something like this. You have an observer at some position O. You have a source here. What will the source do, by the way? The source will give off sound waves. The sound waves will go in all possible directions. I can't make a sphere right now. I will make a circle. And so you can imagine that it will give off sound waves in all possible directions, and this is a circle. As time passes, this circle will keep on going bigger and bigger. Will keep on propagating in all possible directions. It's the same as if you have a lake and then you throw a pebble. Your water waves increases, the diameter keeps on increasing. So after some time, this is the picture that it will be, and then it will give off one more sound wave. And after some time, this keeps on increasing. This becomes this becomes this, and then it gives off one more sound wave. Can you imagine what is happening? Gives off one sound wave in every 1 second, and the other sound wave ka circle keeps on increasing. Yes or no? Good. I am assuming now that the motion will be along this line and my observer is moving towards it. Okay? The sound waves are moving. Acha, what is the distance between each sound wave? This is the distance, and that's lambda. This is also lambda. Now let me ask you this. Does the wavelength of the sound wave has anything to do with the observer ka motion? How fast you are moving, how slower you are moving? Does it matter? It does not. So the wavelength is independent of observer motion. Wavelength of sound is independent of observer motion. Yes or no? The sound waves that will be created out at t equal to 0, so the frequency of sound waves will be what? So V equal to F lambda, F equal to V by lambda, and this is the frequency that we have. And remember, what is V? That's the velocity of sound. Okay? This is the thing that we have. What will the person which is moving with a velocity of V naught towards the source, what will he hear? He will hear an apparent frequency, and what will he perceive the sound waves to move with velocity V? तो उसका बताओ, ये V naught से इधर आ रहा है, sound waves V से इधर आ रहा है. What is the velocity that he will think the sound waves are coming with? V plus V naught or V minus V naught? V plus, na? If your two trains are moving in opposite directions, then your velocities adds, है ना? तो velocity of sound waves perceived by O is equal to V plus V naught. Since the lambda has nothing to do with the observer ka motion, then what is the frequency that he will hear? He will hear this apparent frequency that will be the new velocity of the sound, and the new velocity of the sound is V plus V naught. Yes? And what is the wavelength? Wavelength doesn't change at all. This is lambda. I can eliminate lambda from this equation and that. What is lambda from here? V by F. Then I can substitute and I can get my apparent frequency. That's V plus V naught divided by V into F. and this is the frequency heard by an observer which is moving towards the source. Yes? Can you see that the frequency F apparent is going to be greater than F? Yes or no? Because V plus V naught divided by V is greater than 1. Does it make sense? Good. I took a very special case here where I am going towards the source and source is not moving at all, and I am going in a line which is the line joining the 2 points. I am going in that direction.
Somebody said that as we go closer to the source, the frequency will
Increase.
increase. There's nothing related.
There's not what?
There's nothing related to the distance. Right? As long as you're going in the same speed, it's going to remain the same.
So,
How does it increase as you get closer to the source?
this is the formula. The formula gives you directly, na?
But
Yeah, F apparent is greater than F, na?
yeah, it's greater than us, but that is only when you're moving closer. It's not like it's going to increase as you get closer to the source.
Are to beta, when you are sitting here, what is the frequency that you will hear?
No, not sitting.
You will hear F. As you move towards the source, you will hear F apparent, which is V plus V naught divided by V.
That's great.
Huh.
But I'm saying, like, as you get closer to the source,
Your frequency keeps on increasing, you are saying.
yeah, how does that?
No, that doesn't happen.
It remains the same.
Yes. It only cares about the velocities. It doesn't care about the distances between the two particles. Yes?
Sir, but as we get closer, frequency also increases gradually, right? Then able to
No. एक पॉइंट तक ही रहेगा. अभी मैं डायग्राम एक और बनाऊंगा, देन यू विल अंडरस्टैंड. हाँ अभी गया ना, देखा? बहुत अच्छे एग्जाम्पल्स हो सकते हैं, बट अभी हम लोग एनीवेज. If you were to take a case where your observer is moving away from the source, what will you get then? What will the formula become then?
V minus V naught.
Should be V minus V naught, na? Because now your V naught sign should be changed. And then you can see directly that the frequency will be decreased now. Yes or no? This is the case 1 where I put my source to be stationary and my observer was moving. Now I will flip the roles. I will put the source to be moving now and the observer to be stationary. Okay? So let's do that. Is it written till here? Case 2. Source moving and observer at rest. Source is moving and observer is at rest. Now tell me, will there be a change in wavelength or not?
Yes. So slow.
Let's see. Let's have this is my source, and this is my observer here, and this is the sound wave that it gave off at t equal to 0 when it was not moving at all. After t equal to 1 second, this thing will move a little bit, comes here, and now it gives this sound wave here. Yes or no? You are standing here, you were giving off sound here. After 1 second you came here, now you are giving off sound here. Now let's try to see the whole picture again. Okay? You were standing here, you gave off sound here. After t equal to 1 second you came here, now you are giving off sound here. तो मैं ज़रा डायग्राम अच्छा बनाता हूँ. Is it okay? My circles are not good. But at that one second, in the interval of 1 second, what will happen to this circle? It will become bigger. So ये circle कैसा दिखेगा फिर बताओ? With this to be the center, I think this will become something like this. Yes or no? And now after t equal to 1 more second, what will happen? This will be a little, ये इधर आ गया, let's say. It will give off a circle. this circle will increase, this will increase even bigger, and I think you will get figures like this. Can you imagine? Your source has kept on moving. It keeps on moving. And do you remember what we called this to be, the distance between the two things? That was lambda initially. But now, can you see that the lambda, is it constant? It has changed. It has changed by, अच्छा ये मेरा diagram अच्छा नहीं है, but it will change by the same factor. And what about here? The factor will be different. Do you see?
Then what will be decreasing over that side?
But do you understand this diagram first? Tell me that. I will try to make sense of everything.
So if we call the initial at time 0, the source position as S0, and as the time gets increasing S1, S2, S3, we are making the circles with S0 as the center, right?
No, you are making the circles with the instantaneous position of the source.
Like
At every instant it will give off sound, na? It will not give off sound from the initial position again and again. So this is S0 if for you, S2, S3, whatever. Bol.
even S0 will also keep on producing circles, right?
Are idiot, S0 is not there at all. S0 has moved.
Then how
Source is moving. अरे यार, ये S था इधर, ये S0 की पोजीशन है, यहाँ से एक सर्कल दिया, अब ये सर्कल बड़ा होते जा रहा है, ये रुकेगा नहीं. That circle keeps on increasing. वो sound waves will keep on propagating in each possible direction. अब ये S0 से S1 पोजीशन पे मेरा सोर्स ला के रख दिया, यहाँ पे स्पीकर यहाँ पर आ गया. अब स्पीकर यहाँ नहीं है, और स्पीकर मूव करते जा रहा है.
Okay, but at time is t is equal to 3 seconds, the first circle we do.
What about that sound wave?
Wait.
It will continue to increase, right?
Every circle will continue to increase. बोलो क्या?
Then that distance is going to be lambda.
This distance is going to be lambda.
No, not that. Over there.
This distance.
No, from the source to the other sound wave.
ये चीज. Yes. This will be lambda. But this is not the circle we are talking about. These are the circles we are talking about. आ जाओ. Instantaneously सोचो बेटा. Instantaneously. Don't be very rigid. बोलो.
The circle is at point S0, and the sound wave
Don't talk.
keep on propagated. It is keeping on propagated, and when it is at S1 also, the sound wave keeps on getting propagated.
हाँ.
So what will that wave? So we'll have many more circles, right, like that.
हाँ ये तो करते जाएंगे.
Then what are we considering here as length?
This is my source का position right now.
And what is the?
ये circles. These are all my sound waves which I left off earlier. वो क्या disappear हो जाएंगे क्या?
But they keep on increasing. Right?
हाँ वो तो they keep on increasing with this. Following this law, intensity is proportional to 1 over r square. So as your circle keeps on increasing, the intensity keeps on decreasing, and the circle will keep on increasing, ना? ऐसा तो नहीं होता कि साउंड वेव उधर था, उधर वो स्पीकर उधर है, मैं इधर 10 किलोमीटर दूर हूँ तब भी सेम साउंड वेव आएगा. नहीं, इंटेंसिटी डिक्रीज होता है ना. बोलो आगे.
Now we are considering the distance of the backside from the point to the circle or from the circle to the circle.
क्या बोलना चाहते हो?
वो पीछे का डिस्टेंस है सर.
हाँ.
लैम्डा. वो हम पॉइंट मतलब वो सोर्स.
अभी वो लैम्डा मत कंसिडर करो, वो सोर्स से ही लेना चाहिए. डिड यू अंडरस्टैंड दिस पिक्चर? बोलो. नहीं होएगा बेटा, नहीं होएगा. कॉन्सेंट्रेट कैसे होने वाला है? तुम लोग क्या सोच रहे हो? क्या मैं आइडिया सही से डिलीवर नहीं कर पाया क्या? इट्स क्लियर? इज इट क्लियर टू एवरीवन?
Possible only if the source is moving really fast, right?
No, it's not really true. Arey, your source is moving. That matters. That I understand you are saying ki how did it move so much when the velocity of sound is so high. So approximately according to your picture, I should have something like this. They look concentric, but they are not really concentric, na? Actually, are they concentric? No, they are not. They are like that. Yes or no? Is it okay? Okay. Now let's do the calculation. So F is equal to V by lambda, na? What is the frequency perceived by a person who is standing here? So his free velocity is 0 and this guy is moving with some velocity of s. Yes? So the velocity F apparent is going to be velocity divided by new lambda, lambda dash. Let me find that lambda dash. अब बताओ ये let me wait. So ये मैं सर्कल हटा देता हूँ और ये सर्कल रखते हैं सिर्फ. Is it okay? This distance that we have, what should I write? This distance, that's lambda. ऐसे लेना चाहिए. Actually, I should have taken like this. This distance is lambda, yes or no? This distance is lambda dash. How much distance did you cover from here to here when you come from here to here? That's Vs into t. How much distance did you cover? Vs into capital T, one time period. This is the distance that you covered, na? Yes or no?
Yes.
You covered that distance. So according to this equation, lambda equal to Vst plus lambda dash. So that means my lambda dash should be equal to lambda minus Vst. And what is lambda from that equation? I think that will be equal to Vt. Yes or no? 1 by frequency is time period. So then what will your F apparent become? So F apparent becomes V by V minus Vs into frequency. And this is the formula that you get. Do you understand? And now can you understand from this diagram how frequently you will hear the crest or the rarefraction or whatever of the peak of the wave? How frequently you will hear that will be more, na? Since the distance is so less. And for a person who is standing here, the distance is more, so how frequently you will hear that will be less. Yes or no? That is the whole idea, na? So the frequency has increased, frequency has decreased. Do you understand? This is when the source is moving towards the observer. If you see that now you have a change in denominator and it's V minus Vs, not V plus Vs. If you remember previously, you were moving towards the source and you were V plus V naught. Is it okay with everyone? If the special cases are okay, then I will just give you the general formula now. And bola. Jao. Understanding? ये एलिप्स मत बनाना, सर्कल्स बनाना. बनाया नहीं?
ठीक है, दिमाग में नहीं गया.
अच्छा, ठीक से नहीं गया.
मैंने ऑफिस कंप्लीट.
ठीक है. ओके. बाद में पूछना वापस. बोलो.
The front parts, sir. As the back parts are increasing, front part will come closer and closer and they will touch, right, sir?
They will touch?
Will it touch front parts?
No, ऐसा नहीं होने वाला है.
तो
क्या क्या सोच रहे
concentric
थे?
circle,
नहीं बेटा, वो कॉन्सेंट्रिक सर्कल नहीं है. कॉन्सेंट्रिक सर्कल का मीनिंग क्या होता है?
sir. Same center.
सेम सेंटर दिख रहा है?
नहीं सर, तो फिर वो कैसे होगा सर? वो क्या है?
अरे बाप रे. For those who did not understand this figure, approach me after the lecture. ठीक है? Can I go forward and write the general formula? So the general formula is given to be like this. ये तुम लोग 4 लोग साथ में क्यों बैठे हुए? वो कहीं से भी आवाज़ आएगी मैं तुम लोग के ऊपर ब्लेम करूँगा. साथ में मत बैठो. ये 6 लोग. स्कैटर. फ्रॉम नेक्स्ट क्लास से कोई भी 6 साथ में नहीं दिखना चाहिए. ठीक है? Anyways, the general formula will be the F apparent is given to be V plus or minus Vm Vo divided by V plus or minus Vm. This is the formula at hand. The general formula. And let's try to understand it. Let's try to understand the sign convention first. अब साइन कन्वेंशन क्या होएगा? देखो एक एक का मोशन देखना पड़ेगा और उसके बाद देखना पड़ेगा when to take plus v, when to take minus v, all those things. ठीक है? तो साइन कन्वेंशन is something like this. Let's say source motion. If source is moving, let's say it is moving towards a observer. तो बताओ प्लस vs लेना चाहिए या माइनस vs लेना चाहिए? Source is moving towards the observer. If your source is moving towards, याद रखना source, everything about source comes in denominator, everything about observer comes in numerator. As you move towards it, your frequency should increase. That means the denominator should decrease. तो मुझे add करना चाहिए, subtract करना चाहिए? Subtract. So take minus Vs. Do you understand? Let's take the other case then, where your source is moving away from the observer. Then tell me what do you take? You take plus Vs. Observer motion बताओ. You have this. Should I take plus V naught or minus V naught? Plus V naught. Take plus V naught. And what about the other case? अब बताओ. Take negative V naught, right? Because it's in the numerator. और कम होना चाहिए frequency. That's why it's subtract. What about that Vm? That Vm corresponds to the velocity of the medium. Now understand this कि sound waves are mechanical waves. Mechanical waves meaning they depend on the medium का motion. So if the velocity of the wind is actually supporting the sound wave, that means it's moving in the same direction, then your velocity will be increased actually. So that means should I take plus Vm or minus Vm? Plus Vm. But if your wind is blowing in the opposite direction to the sound ka motion? Minus Vm, because it's actually impeding the motion. Yes or no? So This is what we have. ठीक है? Just for fun, let me ask you an example, and you tell me which is the correct everything. ठीक है? Everyone has written till here? हो गया? लिखो जल्दी जल्दी. Direction of wind affects sound. Sound is dependent on medium, yes or no?
Yeah, but not that much that it literally slows down because wind is going off.
No, it does. It does.
Is it noticeable?
See, you're moving, wind is coming like this. You'll move slowly.